Okay, so this is homework 3, question 8. So in this question, they give you a function and a value, and they want you to find the equation for the tangent line to that function at that x value. So they're calling it at x equals a, and in this case, x would be 4. So the first thing we need to do is think about what do we need to make the equation of a line. So our goal is to make the equation for a line. Now, what do you need to make the equation of a line? You need a slope and a point. So now that point is going to come from the function, from the original function, right? Because this function looks like something, right? So let's do like just a quick sketch of this function real quick. So this is a rational function that x minus 3 can't be algebraic out, so it's going to be a vertical asymptote. So let's put x equals 3 here. This is going to be a vertical asymptote. And then because the degree of the top is 1 and the degree of the bottom is 1, we just take the coefficients, the leading coefficients on top and the leading coefficient on bottom, and that's going to be our horizontal asymptote. So this is x equals 3, and then we'll have a horizontal asymptote here at y equals 5. Now, when you have a vertical asymptote like this, unless you have a squared on bottom, which we don't, we're either going to have something that looks like this or something that looks like this, right? Either the black curves or the orange curves. And to figure that out, we got to think about where is our y or our x-intercept. So here, the function has an x-intercept when y equals 0. And since it's rational, that would mean the top equals 0. So our x-intercept is going to be when the top equals 0. And so 5x equals 0, so x equals 0. So I know that I've got this point here. So that's the only place that my graph is going to touch the x-axis. And so this is what the curve looks like, okay? So now we want a tangent line to that curve when x equals 4. So here's x equals 4. So I need to figure out this point here. So how do I figure that out? Well, I just take my function and I plug in 4. So I'm going to have y equals 5 times 4 over 4 minus 1, which would make 20. I did the math in my head. 4 minus 3, sorry. 20 over 1, which is just 20. So this location here is 4, 20. And so now I need a tangent line to this, right? So I've got my point from my original graph, and now I need the slope of that tangent line. So remember that derivative is just a fancy slope. So what we need to do is find the derivative of this function. Now this function is a quotient, right? It's rational, it's got a top and a bottom. It can't be algebraic out, so we're going to have to use the quotient rule. So let's just do a quick review of that. There's a lot going on in this problem. So the quotient rule is when you want to take the derivative of an f function over a g function, right? So the top we're labeling f, the bottom we're labeling g. We do f prime g minus g prime f over g squared. And that's something that you, like, the more you use it, the better you remember it. So I had a student who called this fig and gif because f prime g looked like fig and g prime f looked like gif. And the product rule was fig plus gif, and the quotient rule was fig minus gif over g squared. There's lots of ways to memorize that quotient rule, but eventually you memorize it. So in this example, the 5x is my f, and the x minus 3 is my g. So how I would set this up is I would say, okay, f is 5x, so f prime is 5, and g is x minus 3, so g prime is 1, right? So the derivative of x is 1, the derivative of minus 3 is 0, because there's no x on it. So now we're going to do f prime g, so that's 5 parentheses x minus 3, subtract g prime f, so 1 times 5x, big divides g squared, so x minus 3 squared. And now we're just going to do like a tiny bit of bookkeeping, really. So I've got 5x minus 15, subtract, and then 1 times 5x is just 5x, over x minus 3 squared. And now 5x and minus 5x end up canceling each other out, which is awesome. So I have negative 15 over x minus 3 squared. Okay, so this is the slope of every tangent line, so every line that's tangent to this graph. Okay, so as long as you know the x, you can just plug the x in to get the slope. So I could tell you x is 1,000,000, and you would say, hey, no problem, let me just plug 1,000,000 in for x into this derivative. I guess I can't really move over to the left here, but I'm going to put y prime, just so you know what I was doing, y prime. So the slope of every line that's tangent to this original graph will be able to be found using negative 15 over x minus 3 squared. But now let's get back to our problem. Our problem had x equals 4, right? That's what we did over here. So to find the slope when x equals 4, what I need to do is plug in x equals 4 to this function. So I'm going to say y prime of 4 is going to be negative 15 over 4 minus 3 squared, which is negative 15 over 1 squared, which is negative 15. So now I have both things. I've got my slope, which is negative 15, and I've got my point from the original function, which is 420. And now I just have to plug it in. And now this is like a preference thing. If you prefer y minus y1 equals m parentheses x minus x1, use it. If you prefer y equals mx plus b, you can also use that, but you have to plug in your xy and then solve for b. So since this question already had like 1,000 steps, I'm just going to use y minus y1, the point slope form. So now we're going to use y minus y1 equals m parentheses x minus x1, where my x1 was 4, my y1 was 20, and my m was negative 15. So I have y minus 20 equals negative 15, parentheses, x minus 4. And get rid of my parentheses, so y minus 20 equals negative 15x plus 60, right? Negative 15 times negative 4. And then I'm going to plus 20 over. So I have y equals negative 15x plus 80. So this here is the equation for the tangent line. So this tangent line is going to just touch that point. Now, let's double check that this makes sense. So there's a couple things that you can kind of double check, and without like graphing this super accurately, you can't like formally check it. Like you could use Desmos and graph the line and graph the function and see if they coincide at one single point, right? But here we don't have that. So let's say that we don't have a graphing calculator. Like, do we know we got the right line? Well, let's think about it. This purple line here, I'm going to make it a little thicker so you can see it. This purple line is going down, 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 right? Starts high, goes low. So its slope should be negative. Well, let's look at our slope. Hey, it's negative. Cool. That looks pretty good. Now, we know that this point that it's touching at is like a height of 20. So is where this touches the y-axis bigger than 20? Well, it should be. Let's look. Oh, yeah. Well, that's 80. So we probably have the right answer, or at least we don't have any like red flags yelling at us saying, hey, you did this wrong. So my final answer, just to be clear, is y equals negative 15x plus 80. And I think the question did ask you to graph. So this is like the idea of the graph. But again, if you're like not so great at that kind of sketching, go ahead, use Desmos.com and make sure that it looks right.